Hello guys, welcome once more to the Me Crash Course, that Crash Course. And we are going to continue from where we left off, okay? So this chapter is going to be all about collections, okay? So without further ado, let's do the usual dance, okay? So let's get here, create a folder. We're going to talk about collections today. And let's start with example one dot. Okay, so I have to increase the zoom level. Okay, so I think this should be visible enough. Then I think we forgot to open it in the terminal as well, so let's open that in the integrated terminal. Okay, so we can remove this out and bring this down, or as of now even remove it. Okay, so collections in Dart. Collections are just list, map, set, or as in other languages known as dictionaries, iterables. So we then going to start with list. Okay, because there's some languages that you hear of list, others you hear of arrays. Okay, so it's basically the same thing, and we're going to start off with list. So lists are simply a collection of values, alright, within which are kind of like stored in a serial manner, and it starts at index 0 up to index n. Okay, so let's start with that first example. Okay, so we're going to have that, and we're going to create a first list. So we're going to say const names is let's go with usual. Okay, fruits, and let's go with apples, some bananas. Okay, let's go some mangoes, and as usual oranges. Okay, so there's that. Now so what do I then mean by it's that's what I meant by it's a collection that holds values, all of them starting with the first value starting at index 0 up to index n. Okay, so um with that now, if we try to point over these fruits, you're going to see that it's going to portray to us that it is actually a list of strings. Okay, because I actually have strings in here. Okay, so that's why it's showing a list of strings. So now the different ways we can manipulate this by trying to print this to the terminal is that we could have different ways of going through, right? So also just for let me just add some fruits here. It's not actually fruits, but just something so that we can have two of them starting with B and B also, right? So bananas bar, so it's not actually a fruit, but I just added that. We'll see that where we'll use that down the line. So let's start then. How then can we go over this list and display the different items in the list? Okay, so we do that by saying by using the for in, right? The for in loop available in Dart. So we say for, okay, say we say final, okay, fruits, okay, in fruits, okay, and nope, we print that out. I don't know why I keep going with names. Okay, so let's say fruits, and if we go down to our terminal, we try to say Dart example one. If I can spell example one dart. Okay, let me bring this up a little bit, and yeah, so you see we have it here. We have the apples, the bananas, the mangoes, the oranges, and the bars. Okay, so that's already one way of how we iterate um, over the elements in a list, and I think we've already seen that. Okay, so we have also seen, I think we also saw something to be able to reverse. Okay, the list. Okay, we saw something like fruits. Okay, in fruits dot reversed. Okay, and then we print. I don't know why my ID is behaving today like this, but nevertheless that's not going to stop us from working. So we can clear this and we save Dart example 1. Okay, and you can see here that it's actually been reversed. Okay, so it's bars, oranges, mangoes, bananas, and apples that have been given to us or printed to us. So there's that. So we can also check if something contains, if something is present in, or if a certain fruit or whatever we want to check is available in our list. Okay, so we can actually say something like if, okay, if fruits that contains, so now it says here that, okay, provide me with the element that you want, and I'm going to return based on that collection. I'm going to return a boolean. Okay, so it's going to return to us a boolean if it is a boolean that's true, if it is present, or false if it is not. So we are now going to check for, let's say we're going to check for bars. Okay, or let's go with yeah, let's go with bars if bars is present. Okay, so for that now we're just going to say if it is, we're just going to print, let's just say element present. So element present, let me move this down, remove that, else I'm going to say print elements not present. Okay, so if we try to clear our console again and run that example 1, so we get element present, pass is present. But if we go with the lowercase b, okay, you see that it's going to say elements not present. Reason why? Because this contains, it's kind of like not actually contains, is that the equality on string, it's actually case sensitive. Okay, so when it tries to do a comparison or an equality on strings, it actually is case sensitive. Okay, so yep, that's that. So we could also check to also display everything that starts maybe with letter B. Okay, if we have any fruits, so we could say something like for final fruits in fruits dot where. So we're going to say, can I take this out, where the fruits, we're going to say where the fruit starts with, we're going to say letter B, and from there we are going to go ahead and print fruit. Okay, so we're going to go there ahead and print with letter B. So let's do that out, and let's do example 1. Okay, and here it prints only what is present, right? So it prints only with, or what starts with only B. That's why I had to add these bars here. So this, we have the bananas and we have the bars. Okay, you could go ahead and try other stuff to see what other stuff also works with. Okay, so we could also, not also withstanding that, we could do something called subscript. Okay, we could try to get elements at particular indices, because remember we said earlier that it starts as on index 0 right to index n. Okay, so we could try getting that by saying fruits. Okay, we could say fruits the element at index 0. Okay, so I think we should store this. Let me see. I don't think we should. Okay, I think it returns to us something. So we could take this directly just in a print statement at once and do this. And as well as we could also do with a square notation, but saying at index 0. Okay, so it's still another form. Okay, so we have here apples. If we did this, okay, at index 3 we have apple, orange. So it's all the same way of doing this. So you could use the square notation, you could just use the element at. Okay, so we also have the and okay, yeah, before I even go forward, if you try to get an element at an index which doesn't actually exist, it's going to crash the application. Okay, so we get this error here, invalid value not inclusive in range. Okay, so it's going to actually crash our application. So we also have the ability to produce sublist. Sublist, I think in JavaScript it should be equivalent to splice. Yeah, I think if it's not splice, it's yeah, splice. Yeah, splice or split. Kind of like I usually just mistaken them, but it's fine. It's just within one of those two. Okay, so what we actually do is that we say fruits. Okay, we say fruits and we say sublist, right? So now you see here it expects a start and an end. Okay, which the end is actually optional. If we don't provide the end, it's going to go right up to the end itself and produce that to us. So if we, for example, say we want starting at index 2, okay, and we want to print, let's just store that in no, we don't even need to store that. We could just use the for each, because every yeah, list has this for each function available to it. So if we just pass here the print, it's going to produce what we call a closure, right? So a closure is going to be produced here, where it's going to take out all of these values, each of these values that are going to start as some index 2, and then now pass it to this print function, which is just going to print them out. Okay, so the print functions actually the for each actually is powerful, so we don't need to store this in a variable and try to print it out. We could just use the for each and just print everything. So if we clear our console or terminal and we say dart example this, okay, we see this mango, oranges and bars, and if we go here, this is actually index 0, index 1. Okay, because we don't start counting as from 1 here. Remember, as for list and everything, we don't start counting as from 1, we start counting as from 0. So we count here 0, 1, okay, 2. So it starts from here, that's why we said 2, and it goes right up to the end, because we didn't provide the end, which is actually optional. And remember, I said if we don't provide an end, it's going to go right up to the end. But if we say here, and let's just say from 1 to maybe 3, okay, and we tried printing that again, then we get just bananas and mangoes, which is actually true, right? It starts from here, bananas, and just ends here at mangoes. If we could even go further and up to 4, okay, and yeah, so we get just bananas, mangoes and oranges, which is what we have here, bananas, mangoes and oranges. Okay, so that's that. And also so to be able to move further now, we're also going to talk about okay, I forgot about even the most important. Okay, to be able to add into this. Okay, so if we say, for example, fruits, yeah, dot art, okay, and if we say grapes, okay, and if we try saying example of this, okay, we get an error, cannot add to an unmodifiable list. Oh, okay, okay, okay. That's because I use const. Okay, because remember that we lastly talked about in the beginning of the introduction of this course. I expatiated more on final and const. Okay, so when you actually say const, it means that you can't reassign the list. That means you actually can do this. You actually can say fruits is equals to something like maybe grapes or something like this. Okay, it's already saying that it's saying const variables can be assigned, right? You can do a reassignment and you can change its internals. So that's what the const keywords does. But when you say final you also can't reassign, so we still can do this. We still can say grapes. Okay, you still can say this, but we can modify its internals. That means we can change what is already inside it. So if we try to clear this out and do that example of this again, then you finally see I think I was to print this out. Let's see, do we also have, can we have the for each available here again? Can we have that? Nope. So we actually have to print and just print the fruits here again. Okay, we just clear that and boom, we have grapes added. Okay, so yeah, so that's that for adding. Okay, so I'm also going to take on something also called we're going to try to compare two, right? So so let's print and let's do this. Okay, so what we're going to try to do here, we're going to have, so we're already just going to take this here and just say fruits 2. Okay, so we're just going to say fruits 2 and we're going to try to compare them. Okay, so let me just take this down again here, just going to, so because we already added there, so to avoid too much confusion, so let's just do that. Okay, and we're going to now come here and compare, say if fruits 1 is equals to fruits 2, okay, then we're going to print they are equal, or yeah, let's just say equal, not equivalent necessary, else not SL, else we just print they are not equal. Okay, so and let's try to clear terminal and then let's run that. So we see here they are not equal. Okay, the reason why they are not equal is because if we try to print each of them their hash code, so let's print that first. So if we try to print fruits1 dot hash code and copy that and say fruits2 hash code, okay, and we clear that and we say this. So the reason why they are not equal is already because behind the scenes where that tries to do a comparison, right, it doesn't only do a comparison using the equality symbol. Let me just use it, let me just go like that. It doesn't just does the comparison using the equality symbol, right? It also uses hash code to compare. So we already see here that the hash codes are different. The hash codes are different even though they have the same amount, they contain the same thing, right? It's, they actually are containing the same thing, but that is actually saying here that hey, they are different. So we could still go and do deep comparison, okay, with that, to actually do that, but that could be a little assignment using the package collection. Sure, I haven't yet done that, but we're going to see that later on in other chapters. Okay, so if we did this fruits 1, okay, so due to the fact that the hash codes are different, that's why it is not the same. So but if we tried comparing fruits 1 and fruits 3, okay, and we did this and we said this again, then they are equal. They are equal simply because this footstool is like pointing to the same location or to the same address in memory where this is stored. So obviously they have the same hash code, and yeah, that's why it's comparison. But here a new address in memory has been created, a new address in memory has been created, and it just compares them based on just their hash codes. But we could through the package collection do a deep comparison, right? So but we are going to see all of that as we move on. So now the last one I'm going to talk about, it's very very powerful, and you are mostly going to be using that. Sure you're always going to be using that. It's called the map, the indentation, it's called the map, it's called the map is it actually called the map? They must call the map function. Okay, so same as we still have our fruits available to us. Okay, we could decide to map. Okay, it's called map. Okay, we could take the string here, str, and say str dot to uppercase. Okay, and the for each, and then we're just going to print here and here. Now you need to take note that the map iterates over a list, right? And it kind of like allows you to convert the items in the list into basically anything. So say we had instead a list of numbers, and we wanted to produce or we just wanted to square those numbers, or let's just say like multiply them by 2. Okay, we won't have to go through maybe say the for loop and multiply each of them and try to store them back in new list. No, with the map it's pretty powerful. We just take each of those individual values or elements, and then we try to do something on them. Okay, so we can say for example here that, and here you see everything now, it's now in uppercase using the maps. And also you need to take down that the map returns an iterable, right? So it's not actually a list, right, but it's an iterable. So if I think we can go to its documentation, yeah, iterable, and iterable. Okay, the base class is iterable, but why for list? Okay, the list for base class can we import? Why are we importing this? Okay, the import isn't that necessary. But for list, if I said here this was a list of string, okay, and we try to go this down, we will see that the list efficient lists. Let's see. Yeah, we see that at the base it's also an iterable. So this is what I meant. So we see that at the end it extends an iterable. If we keep going down, okay, the data analyzer just terminated, but well, you get my point, right? You get my point that at the base class is that it is an iterable, right? It is an iterable also. So there's that. And I think the base class usually for list is something called list base, but you can, that isn't that necessary. I just wanted to show you that at the end the list is also just an iterable, but we're going to see that in later on. So the last also, but not the least, this is actually the last. Okay, at least we've done so many examples already on list. And yeah, so this one we're just going to have a final numbers. Okay, and we're just going to have something like this. Okay, and say for example we wanted to get the sum. Say, so for example somebody asks you to get the sum of this list. It's true you could use the for loop and try to say something like this. Say let's say you're going to say something like var sum. Okay, sum is equals to 0, and you're going to use the for loop and say numbers dot length as far as I is less than that, and you're going to say sum will be equals to plus 0, or the numbers at that index, whatever, right? Yeah, and if we try running that, and then we can come and print, we could come down here and print sum. Okay, and we clear a terminal. No, and we run this and get 36, right? So let's just move this maybe down to not something that much, or let's just say this. So we get 6, right? 6, 1 plus 2 plus 3, 6. So but this is a kind of like plenty of code, yeah, because this could still be performed in a way simpler form by saying we could do something like this. Okay, we could, let me just also comment this out. We could use the fold, so we could say numbers dot fold. Okay, so we see here that the fold gets an initial value 3, and then it gets a function how it is going to combine this initial value and what we're going to get here. So the initial value that we're going to get here is going to be 0, which is the same as this sum. Okay, and we're going to have our prev, let me just call it prev value, that's previous value, and then we're going to say current value. Okay, and basically what we're just going to do here is that we're going to say prev value plus current value. Okay, so let me remove this out. Okay, current value plus prev value, and then this fold returns to us a t. That means it returns to us the data types. You see, we started here with an integer, so obviously it's going to return to us an integer. So if we say final sum is equals to numbers, okay, and we print, and if we print sum, okay, and we do the same thing, we are going to have the same 6. Okay, with fold it's just way simpler and it's less code. I mean, it's way simple. So that's that for list. We have talked so much on list, we have expatiated on them. So now we are also going to work on search. So let's go to example 2. So we're going to say example 2 dot dart. Okay, and so let's start with the main. So now search are just another way of kind of like list, but with list we can kind of like accept duplicates, but with sets we don't take in duplicates, right? It's always tried its best to remove duplicates. So let me come back here and get this list formatted for us. Okay, and let's say we have this, right, and we want to, let's create duplicates for bananas. Okay, from a dart, and then we wanted to create a set. Okay, so we say final, so let's say final unique names. Okay, unique names is equals to, now sets are created using this curly braces, right? So we'll say this, and now you would surely expect that we are just going to say fruits, right? Now, but if you look at the data type, or what it's going to say, it's going to actually say it is a list of strings, right? So that's so it's possible, right? So we could also say fruits, right? And try to print, we should try to print unique names, right? And I'm sure you expect that it should be not example 2 actually, sorry, not example 1, example 2 actually. So you actually expect that it should be duplicates, right? So you see here that it's just one that was printed, right, due to the fact that it's the same hash code, right? Remember, comparison is being done on equality and the hash code, so it's the same hash code. That's why it does this. But if I copy this, okay, if I copy this and pasted this again and said fruits 2, okay, and I came down here and said fruits 2, okay, so check, guess what now is going to happen. Let's clear this, say example this. Okay, so now we actually get them repeated, so it's still the same thing that I explained earlier with hash code, so, and equality. So be mindful of this kind of like little comparison when you're writing your code, because these are things that you could spend hours trying to reason out why it is not going well. It's just this little concept of hash codes and equality. So Not this. So that's at a dot. We now going to use what we call the spread operator, right? So with the spread operator, we're just going to extract these values from this list and now spread them into this unique list. So if we do that again, we just get the apples and mangoes. And you now take note that bananas was twice, but it just appeared once. Okay, so that's that. So say we could even boil this down to just maybe having just three. I think I will remove the oranges and put the mangoes down again. So if we just did that, you see we just have okay, I think it's actually trying to print out. Well, it doesn't mind. It's actually printed out let's two birds. That's not what I actually wanted. I wanted this to be removed and a duplicate here. And then yeah, so if we then do that, we still just have apples, mangoes, bananas. Why we actually have duplicates here. So that's that for that. So that's that for that. And we also, as for list, we can also check if something is contained. All right, so something, no, excuse me, so I don't know why my keyword's crazy. Okay, so we could also check if, for example, unique names dot contains. Okay, we could also check if it contains, for example, what, mangoes. Yeah, let's check if it contains mangoes, and then we just print something like present, right? And then we could say else, we just print and say not present. Okay, so if we just clear this and then we did this and then we see present. But if we had maybe our oranges, okay, oranges, and then we did that, then we see not present. Okay, so there's that for that. So it's also available on search, and let me add this down here. So we could also well, we've also tried to compare two sets, right? So we could also try to compare two sets. So let's say final age is 1 is equals to a set of like 20, 30, 40 and 60, something like this. And then we did this, okay, and then we check again if else if ages 1 is equals to ages 2, then we're going to print here and say they are equal, okay, and copy that, paste that here and say they are not equal. Okay, so we did this and you see they are not equal, the same thing, right? Comparison based on hash code and all of that. So but now let's try to, I think maybe I should try separating this to its own class example, but nope, we're going to do that here. So say for example we had a person class. Okay, let me take this out. And yeah, so say for example I had a class person. Well, I haven't yet talked about class, but we're going to see that. And this class person just has a final string, so it just has a name, and should we call it an int? Let's just say age. Yeah, and then we're going to generate a constructor. Okay, so we're going to generate a constructor for that, and also we're going to overwrite the toString. So we're going to override the toString ourselves. So we're going to say it's going to return just person. We're going to say the name and also the age. Okay, so that should be done. So let's just put something like this, nicely formatted, And also we okay, so with this, let's then try to do a little comparison. So we're going to come down here and say const person one, okay, is equals to person. So we're going to say here Austin, and we're going to say here, let's say for example something like 19. Okay, the argument type string can be assigned, argument type string, so the constructor being called isn't a constant. Okay, so that has been solved. And we have person 2, so we still have Austin age, and let's try to compare that. So this actually isn't actually on the sets, but let me just leave it here. And so let's compare then. Let's say print. Well, we're just going to do the comparison here. Person 1 if it's equal to person 2. Okay, and I think that's that. Okay, so you see here that person 1 and person 2 are true, right? Even though we are not pointing to the same memory location in this case, but behind the scenes is because for this person class we haven't implemented the hash code and the equality. Remember I said that comparison is being done not only with equality but also on the hash code, right? But here we haven't provided the hash code, neither the equality. That's why it says they are the same, right? But if we change the name, obviously they are not going to be the same right now, because they don't have the same name, because it's comparing the name and it's comparing the age and something like that. So they are not the same. But if they have the same name, the same age, then obviously that's that. So now we are going to implement now the hash code. So we're going to go ahead now and implement the hash code for this. So the hash code is now going to be, we're going to use something called object hash. So we're going to say object hash, yeah, object hash. So what we want to hash is just the name and the age, right? Yes. So now it says here that missing corresponding of the equality. So in as much as we compare with hash code, we also have to compare with the equals to. So we are just now going to create this. We're going to compare that. So now the way we do this is that we call upon the identical, right? So it checks whether object references are the same or not. Okay, so and we're going to compare the two objects that we're not going to compare will be this and the other. So now the this here represents to the class we're trying to compare, right? So it could be this person 1 and then the other is person 2, right? So yeah, okay. And as well as if, nope, that's not what I want. Nope. Okay, yeah, this. So if this, it compares using the identical, or it's now going to check that, make sure that the other is a person. First of all, is a person class, right? And we're going to have, okay, nope, and the name is equals to the other, the name, not names, as well as the age is equals to the other dot age. That good. So let's get the formatting. Okay, so well, that's that. So basically this is how then the hash code and the equality are being implemented. And then if we try to see now here that if we get back to this and we try to do this, we are going to get that they are not the same. So let's do this. Okay, example 2. So we still see here that they are still the same, right? Because of this tip comparison that we added here, the hash code and this, but I think they are supposed to. Let's try to print the hash codes, each of their hash codes. Okay, so let's get the person 1 hash code and also the person 2. Let's get the hash code. Okay, so if we do this, then we see that then they are the same, right? Because of this and this, right, is the same thing. So but if we had to change it here to John, obviously they won't be the same then, so it will now be false actually, false. So so that's that for that. So that's that about search and every other thing you could get on it. But okay, that's that. So now let's move on to maps. Okay, let's move on to working with maps. So example 3 dot dot. Example 3 dot dot. So with example 3 dot dot, we are not going to use maps. But what are maps? Maps are actually key value pair collections, right? So we have a key and we have a value. So if we have something like info, okay, and we had something like this, and we had something like maybe name, okay, so we could have something like Austin, okay, and we had something here like say age, okay, we could have something like 19, okay. So this is what we call a map. So the difference with string is that we have these key value pair collections. It's true they start with these, but they are being differentiated by these key value pair collections. Okay, so the same thing we could as well as we could print out the value. So we could say print info dot name, okay, if we want to see the name, okay, and if we did this clear dart example 3, okay, we get Austin. So that's how we print that. And we get to also get the keys and the values, okay, because it's also possible to get the keys. So we could say info dot keys, okay, and also info dot values, and that's that. So we get the values and then we get the keys that are present in the map. So if we could also add a key if it is not present by using something called put if absent. So it's actually some sort of method available. So we could say, for example, info put if absent. So here we're going to provide a key, say for example preferred fruit. So we could say something like 3. Can I actually see what I'm typing? Actually said preferred, or let's just say fruits. So let's just say fruits. Yeah, so with this, then this here we're not going to pass in the fruits, right? Or we could still go with the pref fruits, okay, and we could pass the string, or we could still pass in here and array, say maybe for example apples, mangoes, okay, and that's that. So and if we try now to print again info, okay, and we clear our terminal and did this, then we get now that the pref fruits is not apples and mangoes. So we can basically store basically anything, right? So we could put strings, we could put numbers. I just demonstrated the case where now we are adding a list. We now have a list inside our map. Okay, so that's that. So, and not only through this way we can also do this, okay, we can also do it by this way, okay, by say for example favorite locations or 5 locations, okay, or we could go with the address, okay. We could also do something like info info, let's say address, okay, and we'll say 123 Main Street, okay. So there's that, and we see I didn't actually, okay, we need to print info. Now we clear and we do this .3, and then we get this now 123 Main Street added. So now you might ask yourself, then what's the difference between that? The difference now between that is that between put absent and the second method is that if we try to overwrite this, so the put key with this one, if it already existed, right, and we try to add it again, it's going to overwrite, right? But with a put if absent, if it's already present, and okay, let me just demonstrate it. So if I try doing this, I put if absent, press full again, and I just remove let me just say just bananas here, bananas, okay, and I just remove this, okay, and I clear, and I did this, okay. So for the put if absent, it doesn't, if it's already there, right, it's not going to overwrite already, it's not going to overwrite. But compared to this, if we already had this, we now can overwrite. Here we could have something like Avenue Street, something Avenue, maybe 456 Avenue Street, something like that. And okay, let's try to take this down here and then print info again, and print info. So we now clear that and we do this. So you see here now that we had 123, and now we had to override this now with Avenue 56 string. So that's the difference between put if and the other way of doing this. So if it's already present, it's going to override. If not, it's not going to override. So yeah, that's that for that. Also, we are now going to also get this. So we can also use the for in loop, right? So we can say elements, and the collection here could be info, right? The info, and we could say entries, right? Entries, and be able to get this out. Well, for other languages, they also support tuples, and you could actually do something like this, key and value, or value, something like this. But I think that can do this. But as of now, let me see something. Okay, value, expedite an identifier, final. Okay, map entry string. Well, I think we can actually do something like this, but it screams at me. Change the required pattern to match the value type. The match value of the type entry string isn't assignable. Okay, so it isn't assignable. Let me do this. Okay. So that actually won't work. But other languages do support this, so it's not actually an issue. But well, we could do that here, but just that it will be a little bit more complicated. So, but you can do that. You can take that as an assignment. So we can say here entry, and we could not come here and print entry.key. So we could do this entry.key, and also $ entry.value. So, and then we could come here, do this, and then we get all of this, okay, using the following loop. So as well as we can also check to check by using the contains if something is present or not. Okay, so that's up to you to do that as an assignment to be able to work that out. So now we're going to go to example 4. I think we're not going to take much time on this. Example 4, where we said we're going to talk about I triples. So now Iterables. What are iterables? Iterables are lazily evaluated lists. So meaning that it is called until you start using it. It's the same thing with almost the list keyword, right? The definition that it's resolved only when you start using it. That's the difference between iterables and lists, right? Lists, they get evaluated straightforward, but lists are lazily evaluated until you start using them before they get called. So how then do we do that? We say main, we call upon the main function, we say final iterable iterable is equals to iterable the generate, and let's just say something like 20. Iterate generate something like 20. Okay, and then we could create something like a little get look at get function here. Say not that, say function here, or this function should return, let's just call it a string. Yeah, it should just return a string, nothing much. So we're just going to say get name, and it's just going to take in an integer I, and well, basically what it's just going to say is just going to print, just going to return string is going to be maybe John, or Dewey called Dewey underscore I, and that's all. And yeah, so that's that. So for what we're not going to have here, we're going to have a function that's going to pass that, and we're going to say get name, and it's going to take that I. So, and then we can go ahead and print the iterable. Okay, so clear terminal. I'm going to say example. Nope, that's example 4. Okay, so now you see the difference here is that we have this dot here, means it's lazily evaluated, right? That's how you recognize a iterable from a list. And you see here we end up with this curved brackets, right? This braces here for that. So that's that for iterables, and we print that out. Okay, so as much as we can also, for example, say from this iterable, maybe we just wanted to take. Okay, so say for example we just have this iterable, I wanted to take just two, right? Or we could just say for, let's just say for the following loop for element and iterable dot take just 2. Okay, and then we print just those 2 elements. Okay, so we now clear here and say that example 4, and yeah, so we just take 2. So there's also another function, a method take 2. Okay, that's available on that. So that's that for iterables. And we've talked about the spread operators in list as well, and the spread operators work same too for sets, okay, as well as lists, as well as sets. Okay, so yeah, so that's all. We've come to the end of this chapter. Okay, so can I just maybe just show you the list? Okay, because list also has list generate, and I think it's shall also generating an iterable. Okay, it generates a list. So if we set, for example, this, and we set that example 4. Okay, I think I didn't print this out. Okay, let's print list out also. So if we do this, okay, so you see that the difference with the iterable, it's that it's not everything is being displayed, right? Just the first few elements and the last few elements are being displayed. So if we had to go right up to 100 here, 100, our list is going to try to let me put this up here. You see here that it just displays just the first few elements for the iterable, and some few elements for the at the last part, but for the list it displays everything. So that's an advantage of using iTriples, right? When you want stuff to be resolved lazily, not everything being available at once. So that's that for it. So thank you guys for watching. Don't forget to like, subscribe, and share the video, so that you can help boost the algorithm on YouTube, so that this video can also get to other people. So thank you very much for watching, and it was actually great coding along with you. And let's get prepared for the next chapter, which is also going to be very awesome. Thank you.